Today we're going to be looking at a video on introducing factoring. Some important definitions that I recommend that you look up are factor, monomial, binomial, trinomial, polynomial, and also a prime number and a prime factor. Okay, right now you should be stopping this video, pause it for a few minutes, look up those words and jot them down either in your notebook or on your iPad. Now we're going to be looking at factoring in real life. If you notice, I have some cookies. Who doesn't love cookies? A good question is, why is a dozen 12? Okay, so some of the reasons why that happens is there's multiple ways to split 12. For example, if we had 12 cookies, there's 3 different ways that the cookies could be split. One person could eat all 12, or if you have 2 people, each person would get 6 cookies. And if you had 3 people, each person would get 4 cookies. Then there's the such thing as the baker's dozen, which is 13. Now, why would a baker do this? The reason they would do this is because you would have your 12 of whichever item it is that you have. The reason is you would have 12 and then also an extra cookie, which would then go back to the baker. This would be better than 10 because 10 only has 2 different ways that you would be able to share. If one person would eat all 10, or you could have 2 people that get 5 each. But the difference is that if you have 12 of something, there's 3 different ways to split it, where if you have 10, there's only 2 different ways to split it evenly. Now let's look at factors on a graph. This example here has 4 different factors that are next to y equals. Okay, what you have to do is take the values that make each factor equal 0, and that is then the x-intercept. The x-intercept is where it crosses through on the x-axis. If I take the first factor of 2 and set that equal to 0, we would get a not a true statement. So that would not show up on the graph. Our next factor of x minus 2, we would set that equal to 0, solve for x, and we would find that x is equal to 2. On the graph, you can see that the value of x equals 2, the polynomial function is going through that x-axis. The next factor of x plus 2, we see something very similar. We set it equal to 0 and solve for x, and we get x equals negative 2. And we can see that right on our graph. The last factor of x minus 3, again, we'll set that equal to 0, and we'll get x equals positive 3, which is also on our graph. The last thing we're going to look at today is a factor tree. I'm going to use the example of 48. Okay, the factors of 48 are 2 numbers that multiply to 48. I'm going to use 8 and 6. From there, I'm going to continue my factor tree and get my factors down to the simplest form or the smallest number. Taking all the numbers that multiply. So 4 times 2 is 8, 3 times 2 is 6. 2 can't be made any smaller, however, 4 can. So I'm going to make it 2 times 2, which would then be 4. Okay, all of these values here are the factors of 48. Another way that this may be expressed is called the prime factorization. The prime factorization is when you're multiplying each of the factors. So I would have 2 times 2 times 2 times 3 times 2. Okay, and that's the end of our video. Okay, now next what you need to do is work on some worksheets and practice some problems. Good luck!